In our last video, we looked at how try-catch blocks work and how we can use it to catch exceptions that are in the method we're currently running. But now I'd like to extend that and show you how we can throw errors from one method to another. So let's just start here. This is a very simple class that I created. It's a price list class, and it's creating a static double array that's holding some pricing. And here's a very simple method that is receiving an index, whether it be 0, 1, or 2, and then it's going to return the associated price with that index. And I think you can see fairly quickly that if we received an index of 5, for example, that this method is going to throw an error. It's going to do an array out of index of that error. So let's look at this main my price application. And again, it's very simple. It's just creating a new price list object, and then it's going to prompt the user for the index value, and then print out that associated price based on the value that was input at the console and print it out. And I think you can see fairly quickly what's going to happen. So which price to use? If I use element 1, sure enough, it prints out the second element that was in that array. But if I print out something out of bounds, I'll get that array index out of bounds error, which is an exception that we can catch. Okay. While we're here, I'm just going to point this out. So this will start to have a little more meaning. This is our stack, and the stack gives us an idea of what order things were called in and where things went wrong. And so if you look at this stack, it'll start to have some more meaning. I'm going to make this a little bit bigger so you can see it. And if we look at this stack, we can see that we exited with an error. So when we see system.exit 0, that means everything's okay. System.exit 1, it returned an error when the application ended abruptly in this case. At this first line, this is the first element of the stack. It's the first thing that was called. And you can see that our main method made a call. And here is the file name where that main method is located, priceapplication.java, which is correct. And it made the call from line 16. So on line 16, this call was made, and the new method was placed up on the stack that was called, which was getPrice. So next, getPrice was called. Pricelist.java is the name of that file. That's absolutely true. And it was called on line, it started on line 10. On line 10 threw the error, and line 10 threw this error index out of bounds, and it gave us whatever information it could, and that is that it didn't know what to do with 4. So if you're running lots of lines of code, this gives you a good indication of who threw that error and where it was thrown from, and then you can also follow the order in which the program's running, the stack that it's running. So that can be very helpful. But back to our original problem. So we have an error. I'm going to copy this so I don't have to keep writing it over and over. So we have an error here. Now, we've seen already that we can write a try-catch in our application, and we're going to want to, so that if we get this array index out of bounds, that we'll do something with it. So what we're going to do instead is, or in addition to, is we're going to come into this price list, and we know as coders of creators of this class that there is the potential for whoever uses this class to throw out a bad array index. And so we're going to type the word throws here as part of our method, and we're going to say that if an error is generated in our method, that instead of this method trying to handle it, we're going to throw that error, this exception, to whoever called us. So we're going to catch the error. This method isn't going to do anything, but potentially to whoever calls me, you need to be aware that this is a problem. In other words, let's look at let's look at this. I'm going to erase this for a moment, and I'm going to type in the period. Now, when I look at getPrice, you can see that there is now documentation, and I know this is kind of hard to see because I don't know how to make this little box bigger, but now I can start to see in the documentation of this implementation of this method that there is the potential for it to throw an array index out of bounds exception. And that's getting that information because I told it in the method header that this method potentially can throw this exception. And so now I want to make sure that when I use price list class that I acknowledge in this method that that exception could occur. So I'm going to go back to, I think it was get price, and we're going to put in which index. And so now I know that, well, that's a potential problem, so I need to catch it. And the reason why we want price list to not do anything with it, for example, I could handle that here. If I know that this potentially is going to create an error, I could create a try catch here in this method and deal with it. But the situation with that is because the idea behind this class is that lots of different code can use this class. So this class shouldn't make the decision of what happens with that error. For example, when this class receives the error, it might want to set the price to 55, I'm just saying, and maybe another class doesn't want to automatically set the price. It might want to ask the user for another value. So the point is that we don't want to handle the try catch here in this method. We want to give the ability to whomever calls this method, in this case this price application, to decide for themselves what to do with the error. And so we're going to throw them the error. We're going to let them know that the error is a potential. And then let's do something with it. So let's try. So we're going to set up our try catch here. Let's try that. And if it potentially causes a problem, that method told us that it could put up a array index out of bounds. And maybe this application wants to set price equal to 55. I don't know. Okay. Maybe another application would prefer to catch that error and set price equal to 0. Or maybe loop through the user and tell the user to do it again. Or maybe to set your value to the highest number in the array. So the point is that this class should have the choice. The application should have the choice of what to do with that exception. So let's see, price. We'll just say price is equal to 0. And so now potentially when we run this, which price do we want to use? So 2 will work. That's true. And now if we go out of bounds, we got 0. So this class caught the error and did something with it. Well, let me add on to this idea too. So now we're seeing that we can throw a class from an exception from method to method, which is what we did here. Incidentally, if we don't catch the error, let's do this. Watch this. Okay. So if I use, let's say I use a string here instead. Now here's what happened. When I tried to do the input, I used a string which threw an exception. And so if you look at our stack, the scanner object is what threw that exception, and it threw it at line 864. Okay, because I don't have a catch for that, so this method sent the error, sent the exception to the method that called it, which in this case was here. This method didn't catch that error in any way whatsoever, so this method actually threw the exception to the JVM, which printed it out on our console. So exceptions are being thrown from place to place, but we just haven't caught them in the past. Well, so what are you saying? So now I have to write a catch method to do input mismatch exception. Yes, I could, but how will I sometimes anticipate all the possible exceptions that can get thrown? That seems like it might be kind of hard. Well, that's true. But let's look at, let's see if I can pull it up here. Remember this from our last video or a couple videos before? Each of these exceptions is a child of an exception all the way up to the throwable. So we're currently playing around in this runtime exception, which is also a child of exception, which is a child of throwable. So I could catch any other exceptions. If I don't want to deal with an array index out of bounds, maybe I want to catch all the runtime exceptions. So in other words, I can catch another, I'm going to do another catch, and I'm going to catch all runtime exceptions. Call it something else. System.print line out. I always forget the out dot print line. Something else happened, and then I'll set price equal to 0, so that still will work. So now I'm at least catching all other runtime errors and then still addressing it, so I shouldn't get this next time. So let's go ahead and run that and put in our string, and in fact that string was caught and I went on with it. Now it's very important to remember your hierarchy. In other words, I'm catching runtime exception, which is a parent of the array index out of bounds exceptions. The reason why I suggest this is because when try catches are working, each catch is going to be evaluated when an exception is trying to be handled. If this catch is satisfied, that code will run and all the subsequent catches will be ignored. So in other words, if I had put the parent first, probably even going to get an error, I'm getting this red squiggly line because the compiler is saying, wait a minute, you've caught that error here. Runtime exception catches both of these errors, right? Because it's an apparent of both of these. And so you always need to go in hierarchy from the youngest child, for lack of a better word, to the oldest. So if this one isn't caught, then it'll run to the next one. Well, array index out of bounds is pretty specific, so it's going to catch our array, but it won't catch the string problem, the input mismatch, and so this is a bucket that will catch all the subsequent runtime errors. And in fact, I guess what you really could do to make this more meaningful is you could do ex.getMessage. And then now we have the ability to have a little bit more meaningful. Let's see what that gives us. So if I put in SS, well, it gives us a null. So there was no associated message with that, so that wasn't really helpful in that case, but you get the idea. So now we've seen that exceptions are thrown from method to method. We can catch it in our methods that are calling other methods, and that we can write more than one catch statement.